Now let's talk about fetal heart rate decelerations and the different types that we have here. So the first type is early decelerations. So we'll talk about what this means shortly. So an early deceleration is caused by fetal head compression. So when the head of the fetus is compressed, usually inside of the uterus, you're going to have a decrease in cerebral blood flow because of an increased intracranial pressure. So when you squeeze the head, you're increasing resistance on the intracranial vessels, leading to a decrease in cerebral blood flow. This will happen during uterine contractions during labor and delivery. So the important thing to know is that this fetal heart rate deceleration is normal, and it's not associated with fetal hypoxia or acidemia. So if you see this on a tracing, you don't have to worry too much about it. It's a very common association with uterine contraction. Now, late decelerations. These are very, very important because these are the ones that cause problems and are a sign of fetal hypoxia and acidosis. So this is a fetal heart reflex response to transient hypoxemia. So that means that there's some kind of problem with the placental uterine connection and some kind of problem with blood flow between the placenta and uterus during uterine contraction, causing decreased blood flow to the fetus. So it can be problematic. So these uterine contractions will compress maternal blood vessels and cause a decreased perfusion of the placenta. When you have decreased perfusion of the placenta, you no longer have an oxygen source to the baby, so you temporarily have hypoxemia, and that can lead to acidemia if it happens too frequently. So late deceleration is not a good thing and is a sign of some kind of problem because of compression in maternal blood vessels and decreased placental perfusion. So if you have a benign late deceleration, it will just happen very rarely, not very often, with moderate variability and with accelerations combined with it. So if it's a late deceleration that isn't problematic, you have very few late decelerations with good variability and accelerations. But if you have severe late decelerations, that's when they are recurrent and associated with other problems such as absent or minimal variability and a lack of accelerations. So you see this triad of recurrent late decelerations, variability loss, and no accelerations. You should be very concerned about hypoxia and acidosis. And a recurrent late deceleration by itself is also very bad and is a sign of a major problem. Now variable decelerations. We talked about early and we talked about late. Now let's talk about what variable means. So this, just like early decelerations, can be completely normal. And it's normal and it's not significant if it's transient, as in not recurrent, and associated with accelerations and moderate variability. So variable decelerations are usually okay unless they're associated with major problems. And we'll talk about what's going on here. In variable decelerations, the key is you have compression of the umbilical cord. And this compression of the umbilical cord during contraction causes the variable decelerations, and that causes a heart rate reflex response of a deceleration. It's severe, just like late, if it's recurrent. If it's just a couple here and there with good variability and accelerations, you don't have to worry about it. It's just as benign as an early deceleration. But it's recurrent and associated with absence or minimal variability and a lack of accelerations, that's when you should be concerned about a major problem going on. Now, a sinusoidal pattern. A sinusoidal pattern is when you have a fluctuating fetal heart rate baseline. And we'll talk about what this means in a slide later where we show you a picture, but it means it looks like a sine wave. It goes up and down with a regular amplitude and frequency. And this is a very major problem, and it's associated with severe anemia, also known as fetal hydrops. Fetal hydrops means that you have a swollen baby because of lack of protein due to liver damage, and also an anemia as well. And you also have chorioamnionitis, which is an infection of the chorion and the amnion, and that can all cause a sinusoidal pattern. So now let's talk about early decelerations and take a look at what this image will look like. So take a look. You see the upper graph here is the deceleration itself, and the lower graph is the uterine contraction. And notice how the onset of the deceleration is pretty similar to the onset of the contraction, and the peak of the contraction coincides with the nadir, or the lowest point of deceleration, and you have recovery as well and stopping of the contraction. So in early decelerations, the fetal heart rate curve descends pretty proportionally to how the uterine contraction curve ascends and comes back to baseline. So let's talk about this. The onset of uterine contraction coincides with onset of fetal heart rate deceleration. So you see the contraction right here starts, and you also have the start of the deceleration. So that's a very key feature. They coincide with each other. And you also have a gradual progression of deceleration from baseline to nadir. You see it's more than 30 seconds. It takes a little while to get down to the lowest point of the fetal heart rate deceleration. It's not very rapid. And we'll see what a rapid one looks like later. So a gradual progression of this deceleration. You also have a gradual recovery. Notice that you drop down slowly and you recover slowly. That's another key early deceleration finding. Gradual progression of deceleration and also gradual recovery of deceleration as well. And like we said before, the nadir of the fetal heart rate deceleration is simultaneous and coincides with the peak contraction. Notice how the nadir here and the contraction here, the peak and the trough, are at the same point in time. Very key feature. Now that we talked about early decelerations, now let's talk about late decelerations and what that means. So a late deceleration is just like it says, it's late. So the contraction happens first, and then you've got the deceleration. So the onset of the contraction and the peak of the contraction are before the onset of the deceleration. So the onset of the contraction is always before the onset of the deceleration, and the peak of the contraction can coincide with the onset of the deceleration. But the nadir of the deceleration is always after the peak of the contraction. So some characteristics. The onset of contraction, right here, occurs prior to the onset of deceleration, right here. And that's why it's called a late deceleration. It's very late. So it happens prior. The onset of contraction happens prior to. Very key point. And the peak contraction can coincide with the onset of deceleration, like we mentioned earlier. These are on par with each other. And you also, just like in early deceleration, you have gradual progression of the deceleration. It goes down slowly and recovers slowly as well. So you have a drop to the nadir and back up to recovery in a very slow process. The nadir of deceleration right here coincides approximately at the end of the contraction. So you have the contraction ending and the nadir of the deceleration that are coinciding with each other. So notice that this is late and the previous is early. Early happens simultaneously, late deceleration happens afterward. So now let's talk about our third one. We have our variable decelerations now. So let's talk about what this means. These are a little bit different, and you'll notice that there's not really always a coordination between the deceleration and the contraction. But the main thing you want to notice is how jagged this deceleration is. Notice how sharply it decreases and how sharply it recovers. That's a very key feature. So some characteristics of variable decelerations. You have a rapid deceleration of fetal heart rate from baseline and onset to nadir. Look at that sharp, jagged curve. That's a very key feature of variable decelerations. So rapid deceleration. So this is much faster than the earlier late decelerations, and it also rapidly recovers. So if you see something like this, you should automatically think of a variable deceleration. Jagged appearance. It looks like a little knife that's in the middle of the fetal heart rate tracing. And you want to know also that it doesn't have to be before or after the contraction, simultaneous or after. It's variable, so it can be an early or late, but the way you differentiate it is based on its appearance. So no relation with the uterine contraction. It can happen any time in the uterine contraction cycle. So now I talked to you earlier about the sinusoidal fetal heart rate pattern. Now we're going to talk about what that means. So we're going to bring back some math here and some trigonometry and talk about the sinusoidal wave, or the sine wave, sin for sine. And look at how it goes up and down, up and down, up and down, up and down. This is called the sine wave pattern. And you can tell that you're getting deceleration, acceleration, deceleration, acceleration. If you have this and you have these strong fetal contractions, or uterine contractions, you can tell that there's some kind of sinusoidal pattern going on, and this is very problematic and harmful to the baby. So what are some characteristics? The sine wave pattern, the up and down pattern, that's a key feature of this. And you have repetitive decelerations and recovery. So it's coming down, going up, coming down, going up. But you always want to make sure that when you read these different graphs, you remember that the fetal heart rate is always on top and the uterine contraction pressure is on the bottom. And remember, the sinusoidal fetal heart rate pattern happens with some kind of fetal distress or major fetal problems. It can be from fetal blood loss, such as vasa previa or a rupture of placenta. It can happen from anemia, from fetal hydrops, or it can even happen from chorioamnionitis. So sinusoidal patterns are very important to know.